Welcome to this video on how to run fuel station locally. So let's first check the documentation. The fuel station is a gas payment paymaster on the fuel network. It uses um, the UTX model, which is the unused transaction output model. So which allows for parallelism, making the process transaction faster than other than is possible on Ethereum. So this is how it works. So uh, it is a non-custodial gas paymaster. So anybody can conduct transaction and have all their various input and outputs. We we can accept, and there will be an output for each person. So they can rent coins on demand. So when this paymaster is launched, it's going to create like uh, multiple coin that can be used to cover the gas fees. So uh, later on, the user can rent any of them to cover their gas by spending an intent. So how does the authorization work? So yeah, the master is going to sign an intent. He's going to the predicate. So the paymaster owns a client that handles all this intent-based authorization. And how does the authorization work? So when the paymaster signs an intent for a user that goes into a predicate, the coin moves if that intent is signed by the paymaster. That's contain the paymaster's signature, and also this thing uh, protects against reentrancy or replay attacks by using the coins by generating a UTX ID. So when the transaction is done, it is destroyed. So this is an example of how the intent object looks like. So then we have the how the interaction works. So the whole point of Gas Paymaster is to allow users to perform transactions without having to hold it natively. That is to hold it or fuel tokens. So they don't have to. So whatever coins they might be holding stable coin or any other coin they have, so they can use it to run transactions without needing them to always be holding the native coin. So Paymasters handles all this because it holds the it coin itself. It holds the it coin natively. So it's going to be borrowing it depending on how much the the user need for their transaction, the amount of gas they need. So and using the UTXO model, so everything is basically on the input output. So the input from the user, the input from the gas master as well with the signature. So it gives it if the among the accounts that is being monitored that is owned by this paymaster has 500,000 of units of gas, and this person needs 200 units of gas to run their transaction. So it's going to be wrapped together and going to the transaction and executed. So the output goes out, whatever the output it goes out for the user. But the payment, the output goes back to the so input and output. So the output comes from the transaction and these inputs are destroyed and the outputs are returned and created as a coin or as a token. Then they send back to the paymaster. So the user doesn't have to be uh, always signing for always approving gas from his own token or needing to be holding US token, native token of fuel or holding each token. So benefits of this uh, to users to users and to dApps is that the dApps can sponsor the fee on behalf of their users, and it's ideal for modern new users that are not used with the transaction signing and everything. Because most users are not is actually not a good user experience for the user to have to be always, if you want to perform a transaction in a particular on your blockchain, and they need to have a unique token, and they have their own particular token that is in your wallet, and because of that they can't execute. They have to be maybe bridging and so on. So this abstracts it all the way. This Paymaster by first station abstracts all this complexity away using their um using their first station. Yes, using the Paymaster, and it's non-custodial, so you don't need to have any custody of any funds. You don't need to hold any fund Paymaster to do it, which is unlike what most solutions of Paymaster have provided over the years. So there is kind of a policy. Okay, so now let's start running our um. So to run this tutorial on how to run first station, so we copy this, then we go into our VS Code. So okay, so yes, so we clone the repo. Good. I think we clone it. Yeah, full station. Yeah, this is yeah, we select it. So this repository, this project has the uh, the code we have, the need to perform um, has the code we need to perform the gasless transfer. So we are going to look at the book right here. Actually, I can open it on my system on my local machine, but I think I prefer seeing it from here. Okay, so let's start with how to run this locally. So before you start running this thing, there are some prerequisites you need. So you need to have Superbase installed. So if you don't have it, just click on this link. So depending on your own operating system, you can get it installed. So after installing it, yeah, I think you're okay. Just do this. Just do any of this, depending on your needs. So when you are done, the next thing you also need is to have a Docker desktop or engine on your local machine. So you run your you install if you don't have Docker. So let me see how we can get that. So you also click here. So when you download the one for your various machine, mine is Windows, so I selected for Windows and I downloaded it and installed it. So there's one last thing you need to do. So after installing your Docker desktop, you need to go to settings. Yeah, then go to resources. Is it general? Okay, so by default, this guy will not be enabled. So you need to enable this guy, then you need to enable this expose this daemon. So you need to make sure these two are enabled depending on your machine. If you're using Mac, I don't think you need to do this WS or something, but you need to make sure that anything like this guy is enabled and you expose it on this guy. So yeah, then we are good. So then after having the Depto and Superbase installed, so let's also see what other prerequisites we also need. So we need to have one installed, so which is actually quite simple. Go to this web page. So depending on your operating system, you install it, that works for you. So after you have it installed, then you are good. Okay, so after cloning the repo that we've already done already, after cloning the repo, so we need to open uh, deforestation. So I have it open there already. So then we have to go install. So then let's start doing that. I don't think I need to, because I think I've already done that. Okay, while that one is running, then the next thing is to okay, let's now do the service start. Then we can do that now. So yeah, so that's it. You have your packages installed. Then the next thing is let me open a new terminal. So this command service starts. So this actually took 40 to 50 minutes on my local before I was able to. It's going to download the Docker images and containers and dependencies and everything it needs. So you can see that everything is up and running now. It's already running. You can see it. So it took like about 40 to 50 minutes on my computer. And I thought I actually have a decent computer. So because I have my machine is 24 gig RAM, 24 gigabyte RAM, and use SSD. So it took, but I don't think on Mac it should take on 20 minutes. But depending on your configuration, it shouldn't take too long. So when everything is done, all of this will be up and running. All of this. So okay. So another thing you need to do is you need to create this guy. You need to have our environment variables. Let's keep it out. So yeah, so we have all this. So this guy, this service will automatically go here, so you don't need to do anything. So this service key, since we have this guy launched now, so we can just press Superbase status. So this will show you your service. Okay, so you copy all this from here to here. You copy it, then paste it here. So yeah, so let me see. So that's good. So by default, this project comes with a private key that is funded for local dev, local node. So we are going to be running, when we are running our Paymaster, so we will need this private key to do some deployments and other stuff. And while doing it, it's also going to be used by, okay, yeah, now I need to generate a mnemonic. So there are some scripts available already. You can see them here. There is generate mnemonic. So looking at the package of JSON, you can see the command is here. Is this one done? Yeah, it's done. So you can see on then so we have our mnemonic from here to here. So I'm going to copy that. I put it in our in as so we put it in a quotes. So it's going to be using that we are trying to start the fuel station server locally. So while looking at our documentation earlier, I said it's going to generate some multiple accounts for you. So yeah, that is going to look and perform with it. So it needs that mnemonic and private key to do all that by itself. So yeah, so the next step is you have to generate the GWT token. So this thing doesn't say that you need. Let's go through the code. There's a code inside there somewhere. So in this place, yeah, you can see it needs the swap and this needs the file provider URL. Yeah, this provider URL we are going to launch our own local node. Wait. Okay, so before we run our so before we can run this server, we need the local node to be up and running. So we can see it in the env, the local node, yeah, the local node URL is provided at this place. So we need to make sure it's up and running. So on my own local machine, I have it installed on okay, yeah, let's go to the make file. There's a make file for that. So this is the make file. You can see the fuel core. So by running this command, it's going to do this thing for you. It's going to launch the local node without persistence. That means after we cancel it, it's so you can see that we need fuel core and so that's what we're going to do. This is documentation. So we look at how you can connect to network. So these are the RPC available. You can see them for testing and mainnet. So we want the one for local node. So we select local node fuel node. So to launch a local node, you need yeah, this fuel node is really available in the package. So this fuel core, we need to install. Yeah, let's click that. So yeah, we're using the fuel core. Before we can use the fuel core, we need to install the fuel core. Yeah, we need to install the fuel tool chain that handles everything for us. So I recommend using this fuel of init. So you copy this, open your terminal. If you're on the Mac, you open your any terminal, use Linux terminal, but as this is a my Windows computer using WSL, I have to open my WSL then put the command there, then do this. So I'm sure, yeah, I've already installed it, so I don't need to do it. Let me cancel that. So if you want to be sure that it's up and running, there is a command for that. So you type this guy for version, then you type it. So I can say I have fuel up 0.270. So I have fuel up up and running. So I can go back to run this local node. So we're using the method of business for call. So before you do that, make sure you run this guy so you can um, increase the limits of your memory of your local machine. So yeah, after doing that, then next thing is you need to run this guy. So we don't need to bother with running this one. Inside the project, you have the code there already. So you just come to the make file, you can see the full core. So just come, make sure, okay, yeah, if you are using Windows and WSA, make sure you open the WSA there. You run make full core. So yeah, the local node is up, the blockchain is up and running. So let's check our ENV. What else are we missing? So everything is filled up. Yeah, yeah, yeah. So I think we are good. And this also make also give us the command for running the Power Station server. So run the Power Station server, can just do make start. Okay, it's not recognizing it. So let's do burn run this. So it's closing because yeah, GWT private key is needed and max value per coin is needed. So we need all these variable. They were not included there by default. So you copy this guy, come to your env. So I initially did something similar. Let me open my, let's see, open notepad. So I chose 1, 2, 3. So yeah, 0.00 in full network, 1 million, sorry, 1 billion. That is 1 times 10 to the power 9 is equal to 1 ETH. So this is approximately equals to, should I say 1 milli ETH? So let's put this guy, just put that 1,000 here. So I'm first 1,000 into 1 million. So then we copy the JWT token, JWT private key, we copy it and we paste it here. Very important. This is going to be handling our authenticity token, pass token for the first server. So then we come to this place where the script is there already to generate the W token. You can see it. The script is there already. So just come to package and JSON. I'm sure it has the code. Oh yeah. So we copy this guy. Then we come over here. Then we do burn on. So yeah, we have. Let's go to our env file again. So we have our private key. So we copy it. DWT private key. Let me see, is it part of it? Yeah, that equals is part of it. Okay. So we paste it here. So this actually gave me a lot of stress. Everything has to come So there we have our full AW token. So let's now run our local machine server once again. Okay, so yeah, everything is working. So it's active on port 3000. This is what it is. So I'm having this issue that so the file core version is 0.40 and the file core version is 0.41.9. So I installed the latest, so I should have, let me see. So I should have found the corresponding version, but everything still work fine. So I'm sure that it's expecting 0.40, zero point 0 and 0.41.91, so it's, everything still work fine. So yeah, okay. So the server, so the first station is now active. The server is active. The um, blockchain is running. So let's look at the next step. So yeah, we have it active. And so the next thing is the third step. So it's second step. So we are at second step where get um we try and run a demo of the gasless transfer token service. So the first station works over a REST endpoint. So we are going to copy, we are going to scroll to our, so let's do another. So you go to, so this is where the gasless token service, sorry, yeah, is in this example contract. The gasless token service example is here. So you can see a dummy contract, a dummy stablecoin contract written in Sway. You can see it here. So we're going to have to deploy it. So before we deploy, we need what we call um, we need to have our ENV available. So now looking at this thing, we need where is this ENV example here? So we need these two. This has to be there. Yes, that has to be there. We also need this private key to deploy. You can use any private key as long as you make sure it's funded. This one is funded by default from from the fraud team. So we can use it to deploy because we are going to be needing itself some token. So let's look at some of the scripts. Yeah, you can see there are some scripts available here. So let's go into the documentation again. Yeah, just prefer, so you can see how the gasless token transfer the project example project works. It has a smart contract written this way for a stable coin. So how to deploy it, then it has all these script for us to use. So since we are inside this place, since we are inside this directory, now so we need to uninstall. We need to install the packages. Okay. So write down continuous. So we need to deploy. So we need to deploy To learn more about that deploy was everything's in this code. This is the deploy script. So let's see if it works. No, it doesn't work. Something is missing. Yeah, it needs this auth token. Auth token has to be there. It also needs station server URL. Let's go into our email. So station server, we need to cancel this for underscore. It also needs private key, so we need to cancel this for founder. It needs what else again? It needs this provider URL, so we need to cancel this. Yeah. So I think that's all. Yes. So we need to put the auth token. So how do you get the auth token? So since we have our local machine, the local server running already. This is it. Where is it? Yeah, it's already running here at 3,000. So we go here and write 127, or we can just copy the address from the EMV. This is it. Yeah, just copy it from here and come to our. So we need to do slash token. So this is your authentication token. So you copy it. If you notice, I think it's the same as the token we copied from the, let me see, service low token. Where is it? Where is this guy? So yeah, if you look at service low token, I think it's the same. Yeah. But I prefer you go to that slash token to go and copy it, because that's the one that is in the database for you to use by the server. So now let's not try our let's try to deploy the contract again. So also on deploy. So after it's deployed, you see that the where is it? Install documentation. Oh, this okay, we are done with this. So we come to the it's going to everything's going to be available at the deployment dot JSON. Where is it? Yeah, you see. So this I know that your deployment is successful. So this is the contract ID of the stablecoin that we deploy. This is the assets ID. This is just when it's talking about the assets that the contract has. This one is just to identify the contract itself. This identifies the assets owned by the contract. So this is the why only this deploy? We deployed we created an account that we are going to be using. We can't use the account that we used for deploying. So we want to use a user account, right? So that has no balance at all. So we are going to meet some token to this account. So that's what we did. If you go to the deploy token, you see everything. So let's now go into according to the documentation. So after running deploy, then you now meet the let's now meet the stable coin at this address that we just created. So where is it? Where is the at this address that is here. So now let's do that environment. So yeah, you can see it has successfully minted an amount of this is 0x64 means 100 in decimal. So it's also minted. So now we cannot change the balance. So we cannot check the balance of the address, that's our full address of for this stable coin. How much of that stable coin is good? So we can go here and do like this. You can see it's holding one coin, and the amount of this guy is holding is 0x64. So now let's try to mint. Yeah, we now try to. So this is where things get quite interesting. So now this is how you actually use the gasless client to do some action, to do some transfer. So we're going to run one on transfer. Actually, it's not transfer because if you look at the package of this thing, it is send that is there. So we do that. So write send. So something is failing. Balance not found. Okay, let's look at the code. Balance not found. How long is provider? So it says balance not found. Let's see. Let me see if they are both running. Okay, the first station is running and the blockchain is still running. So we are still good. And I can confirm yeah, the database is still running. So it's not working. Then we try to run bond deposit. Okay, it's not found. So we have to run it ourselves. Dot ts and it's under scripts. So scripts. So what I do is I just there was some I just wanted our verification token. So let's now run our send again. So yes, successful. No unlocked account found. Okay, so before we can do this, we need to unlock the account. So we need to go back to our yes. So this thing is here. So we have these scripts here. Where is the script? Yeah, the scripts are here. No, yes, these scripts we have unlock all accounts. So let's see the commands for that in packaging this thing. Unlock account. So yeah, quit this guy. So do burn run unlock accounts. So accounts have been unlocked. Then we now go back to this place. Accounts not found. This will become token. Account not found. Okay, let's look at some. Look at this one. Let's not balance. Let's check the balance. So we still have our amounts there, but we can't find the accounts. So I believe we need to account not found. This one is still unlocking accounts. Yeah. And the so now Baron send has make the Gasless token transfer and it succeeded. You can see uh, TX status success. Balance after transfer. Receiver balance before was 0. Now the receiver balance is now the balance. The This is the account that we created after that we are sending from our generated from the wallet from the full account that we created in the deployment your GST. So that account is sending to another account. So this is the receiver account that it is sending to. So we maintain token to that fuel account, and use we now use we use Paymaster to send him to do the transaction, and it went. And the of course you can see when we maintain to the fuel account was a what we maintain to the fuel account uh was a stable coin. It's just a generic stable coin, a dummy stable coin. I don't know the name, but it's not an Ethereum token. And we're able to perform transaction. Or it is not a full token, we're able to perform transaction without any native token. So this is okay. So let me now check the balance of the full account that is in our deployment of JSON. You can see it has turned to 0. It was 64 before, but it's now 0. So which means this Paymaster works as expected. So let's go into the next phase. So yeah, we check the balance after we did this research. So let's go to the transfer, which is the major code here. So let me zoom in a bit. So let's go to the code. So these are just the necessary imports from this is imported from the first package. This is imported from um all these are done. All these are done inside the this from our deployment of JSON. We are getting the asset ID and the file account that we minted the token to. Then this station, gas station client, this is available here. You can see it in this source. Um, where is the link? So you can see how it works. This is partition. It is an instance of the client. It takes the token, the file provider, the endpoint. So it has this generate token. That's how we are getting the token when we go to slash token that we use for additional token. Then it has its deposit. So before you make any um minting, before you make any minting, make sure you deposit a balance. Let's go to the code. So before make sure you deposit that deposit is going to deposit into your token. So it's giving your token, it's going to check the balance of your token if you have that amount. If not, you won't be able to perform any transaction. So this is the send transaction function that does the allocate coin request and response. And this is the response. This is the gas coin. This is an instance of the gas coin. So these are um, altcoin and the altcoin input and output. So this is the output. These are the code. So you can go to it later. So let's go to the main code. With this transfer. So after importing this gas station client and this transfer, So then, so we, of course, we import our provider from, which is our local, and in this instance, our local node. So we import it, then we, the wallet that is inside uh, the JSON that we created and minted token to. Then this is our authentication token. So we import it as well. So then the gas, so we create an instance of the gas, the Paymaster client. So after doing that, then we now check the balance of the token. You can see that this gas station doesn't take in any private key or of the account of this wallet that we are importing. It didn't take anything like that. So what it is with this token, so it's going to check the balance of that token. And you have to make sure that your token is has a particular amount, at least it is not equal to zero. It won't work. So you need to, if it's less than or equal to zero, you need to make sure you deposit. You run this script. This script is going to deposit amount of 0.018. So that means your authentication token allows you. That means the user, you the developer, that's the token that will be used by a user to perform some uh transactions. So let's go back to our yeah. So now, so after checking that, okay, this is okay, then and we created our instance of this gas station client. So we now create a random wallet. Basically, we are burning the token we mint and the stable domain. So we don't need to. We're just creating a random wallet, a random account. So we didn't really save the private key or public key because we are burning it. So we now create a request, which is an instance of this script request that is going to be signed by the uh, Paymaster client. So we get from our wallet that we installed from that we imported from our deployment token, we get the coins for that particular asset, all the coins that it has, it brings it, and then we now add these. So we add, so how the UX UTXO works is it's basically based on input and output. So we add the coin input, that means the coin that we have. So this is the input from the for that was our transaction. I want to make a transaction for this thing. So this is the input, our input that we are putting here, just like how we did here when we came here. So our input is that wrapped in that is inside our input is that coin that we want to send out to the wallet we generated. So this is the input from the paymaster. He's going to know, he's going to sign it with an intent signature. Then he's going to know, okay, this is the, he's going to estimate the amount of gas that we need. Everything is being handled by this gas client instance. You can take the code now. So then taking it together is going to come into, is going to be exceeded by the referral network. Then the output we go to. So the remainder of the gas, if the gas given by the paymaster was too much, it's going to recover the excess back into the paymaster. So this is what is happening here now. So we have our inputs that we want to transfer to we like want to transfer a token from our to a wallet in different adjacent to a random wallet somewhere. Basically, we are burning. So then the output to be added as well. So the output is the receiver address, and we also see that the first instance of the coin and amount. So it's going to take in that. Then it's going to take in the, so it has to be the same asset, the same, I should say, the same token something, the same asset that this one is having, that is going to be increased by this amount. So then we send the transaction, then we wrap up all these things into this same transaction under the paymaster clients using the request. So we have the request and we wrap our wallet. Our wallet, here's the wallet. So yeah, here's the wallet. So these are wallet that we imported. So it's going to wrap it together and it's going to process it. And so from the results, so we wait for the result, then we can see the um, status that give us transaction status it was successful. So it also gives us the balance of receiver after. So we are getting the balance of the receiver before the client makes the transaction, and we can see the balance after. So which shows the successful message. Let me go to let me zoom out. So this is it. So TX was successful. So before of the burner wallet, burner account, and after the burner account has the mutant token. And we can see that in our balance of our deployment.json accounts, so there's nothing there. So that wraps it up for the gas payments on fuel station reason for. So always be sure you check the version of your local node and hope it works with your hope it works with your version of fuel core as well or the SDK you are using. So yeah, so one final thing, there was an instance where you might have account not found, account not unlocked. So just ensure that you run this command, unlock all accounts. And if it's still giving that, so you run this where is it? Clear database. So, yeah, so database um might have been how should I say it? Maybe outdated with the current information data. So clear the DB. So you clear the database and um you clear the database, then you make sure that you get the token again. When you are in this repository, let me go there. You can just use call to get a new token. Just do call local and get a new token. So that is the token. So yeah, this token will be your token. And you're going to put it in your. So there we have it. We're able to perform uh Gasless transaction without having any token through first station payments, Paymaster. So we're able to be able to perform first station gasless transaction. I believe with this overview of how to run these commands and run these scripts, we should be able to apply it into our own tasks and project and allow our users to run um, transactions without holding any native token. So this will easily onboard more users, allow onboard of more users, and allow improve UX for the users as well. So thank you.